We're looking at problems 9 and 10 from the review for Performance 8. And number 9 says we've got this function f of x equals x to the 2/3 power, which if you look at the graph, I believe looks something like this. There's 0 and we've got this interval that runs from 0 to 1. And we know that the function is continuous and differentiable on an interval. So this right here would be the slope of the secant. And we want to find that point right there, which we're going to call C, where the slope of the tangent is the same. This is a 3-step process. Step 1 is to find the slope of the secant, or in other words, the average rate of change. That would be f of 1 minus f of 0 over 1 minus 0. And if you calculate that out, you will get 1. Step 2, find the slope of the tangent. Now the slope of the tangent changes from point to point to point, depending on the steepness of the curve. So that would be the derivative of the function. The derivative of the function is 2/3 x to the negative 1/3. I don't like negative exponents, so I will write that this way. Step 3, and the final step, is we want to know when the slope of that tangent is equal to the slope of the secant. Therefore, we will set 2 over 3x to the 1/3 equal to 1. When you do that, I did a little cross multiplying and I came up with x to the 1/3 power is equal to 2/3, which means that x will be equal to 2/3 to the 3rd power. So x is going to end up being 8 over 27. Notice that 8 over 27 is on the interval between 0 and 1. Which is exactly what the mean value theorem said has to be true. Take a look at problem 10. This is another problem you should be able to do without a calculator. Problem 10 says, explain why the mean value theorem does not apply for this function on the interval from -1 to 2. And so you look at this function and you say, oh, okay, well, it's not defined at 0, so it's not going to be continuous there either. Or differentiable. And therefore it violates the conditions, which means that it doesn't necessarily need to meet the conclusion.